Hey there, everyone. Welcome to the most important topic of the Hyperledger Fabric, that is the transaction flow. So, if you understand this Hyperledger Fabric transaction flow, 80% of the fabric you are already aware. How internal these transactions happens, who endows the transaction, who invoke the transactions, how block get created, how this data get committed on the ledger. So, these all the things we are going to cover in this video. So, you make sure please to understand this all the concept. First of all, the network topology right now we can see on the screen. We have three peer organization and one order organization. We're not talking about our document management right now. Just keep that right now aside. So this transaction flow we are going to cover for the three organization. It would be easy to understand first. Okay, on the bottom side we can see there is a user who initiate the transaction. So when we invoke the transaction as a user, what exactly data we just send? We were creating the contract, right? Agreement, it's having different data, document, first party, second party, name of the contract, terms and condition or any comment. Okay, this is the payload, actually this payload. The user is sending transaction payload to the API server from the postman. We have already seen that part. Now, when this API is getting this transaction, what exactly they are doing? API server is creating transaction proposal. Let me just show you here. In the agreement service, when we initiate the transaction, we are getting a contract object. Okay, so this contract object, how it is getting created? We are just connecting the gateway here. Gateway equal to connect, and we are providing client identity and signer. The most important thing here, we have client. Okay, this is the client, and target peer is the client for us right now from the API, because this API server will send this data to the target peer, and in our case peer 0 organization 1 is the target peer. I'm considering this user from the organization 1, so this is getting selected dynamically peer 0, and if logged in user is organization 1, it will be peer 0 organization 1. In case if user is organization 2, so that will be peer 0 organization 2. So we are targeting this transaction to the peer 0 organization 1 as a user of organization 1. Okay, so this transaction will get created. First of all, this transaction will create as a signed proposal. Let me just show you how exactly looks like. Okay, this is the signed proposal. So proposal having some function name, some arguments, chain code ID and a channel ID. Okay, this proposal byte created, we convert into the hash, and this hash will get signed with the private key of the user. So that is happening at the API side. On the behalf of the user, API server is doing all these things. And finally, we get on signature using this private key. When we sign this hash, we'll get on signature. And this signature we put into the signed proposal. So signed proposal, we can see here, proposal at a byte we already have. And one more thing is the signature. So along with these two things, we call as a signed proposal. So this signed proposal got created at the API side in our case. Let's go to the transaction flow again. Okay, here, this signed proposal get created at the API side. Now what exactly API does? It connect to the gateway, and using gateway, it connect to the peer, their own organization peer. So for this organization 1, we have peer 0 is the available peer. So this client API server will connect to the peer 0. Now peer 0 responsibility to send this transaction to all the endorsing peer in the network. Previously in the Fabric version 2.2, 2.3 and lower, means after 2.3 they introduced a new transaction flow, but before 2.2, so there was a discovery service at the API side only. We used to fetch this information like who are the endorsing peer, how many endorsements we require for this channel and this chain code, everything we used to do at the API side. Now this peer 0 is going to do for us. We don't need to do, we have to just send a signed proposal to this peer. So this peer will just check how many endorsements are required for this transaction, how many endorsing peers are up and running, everything will be checked at this phase only. And now this peer will send this same transaction proposal to the other endorsing peer in the other organization. Okay, in the second phase, you can see here, this peer is sending transaction. Okay, this peer is sending itself the second and second here. And this peer 0 from organization 2, peer 0 from organization 3, and itself peer 0 also. Now they will simulate the transaction. What exactly they does? First of all, they will just check whether a transaction is well formed, it has a valid signature. Again, signature verification, I will let you know. Second part is signature verification, and third one, they will check as per the policy defined in the channel configuration block whether this user is allowed to do the transactions or not. There are writer policy. When we talk about the config.text.yaml file, initially we have embedded this all the policy who can write into the channel, so that all the validation happen whether this user is authorized to perform this operation or not. Okay, all this is the third validation, and finally this peer will endorse the transaction. They will create a read set and a write set, and finally sign that again transaction and send back to the same peer. This peer 0 from organization 3, peer 0 from organization 2 also send back this response. That is the proposal response to the peer 0. Now it's peer 0 again collect all the endorsement response from different peer. Again by himself as well, he does the endorsement. The same validation will happen. First one is the user is valid or not, signature is valid or not, whether he has authority perform this transaction or not. This all validation happen at the endorsement phase. And endorsing peer have special capability to endorse the transaction using this smart contract. All the endorsing peer will have the smart contract. They will simulate the transactions as per the method we have invoked. They will simulate the transactions and create a endorsement response and finally send to the peer 0. Peer 0 just collect all the responses and finally create a transaction. Okay, the transaction will have now a transaction envelope. Okay, first thing. Second one is the proposal response got from the endorsing peers. Like it will have a read set, write set, and it will have finally endorsements. And this transaction submission will happen to the orderer. Okay, let's consider this peer will send this transaction to the one of the orderer. Orderer will again send this to the leader, orderer in the organization at that point of time. And finally, this leader ordering service will create a block. They will just chronologically order the transactions, and as per the batch size and batch time we define in the config.text.yaml file, it will create a block. So right now we have configuration within a 2 second or 10 transaction, whichever comes earlier. So let's consider within a 1 second we got 20 transaction, it will create a 2 block immediately. Or within a 3 second we got only 1 transaction. Immediately after 2 second, this order will create a block and just send this block to the leader pair of the all the organization. So right now peer organization 2 or organization 1, we have only one peer, and at that time they are the leader peer. Again, leader peer selection is the dynamic process or could be static process. It depends on the configuration how we do when we start the services. Right now just consider we have a dynamic process, and for organization 1 and organization 2 they have peer 0 as the leader peer, and for organization 3 we have one more peer. Peer 1 is not an endorsing peer, so it's just a general peer, committing peer we can say. So in that case, orderer when send this block to the leader pair, and peer 0 is the leader pair at particular time. So one of the peer goes down, so other peer will get selected immediately, and there is a election process for selection of the leader pair as well. So for time being, let's consider peer 0 is the leader pair. This orderer will not send this block to peer 1 and peer 0. This orderer will just send this block to leader pair of the organization. There is a possibility this organization can have n number of peers. So for reducing the burden of the ordering service, the community has introduced the leader pair in the 1.3 or something. Not sure about the version, but they have introduced the leader pair. The orderer will send this block to the leader pair only. Now it's leader pair's responsibility to send that block to all the other pair in the organization. Okay, this peer 0 get a block, he just send that block to the peer 1 as well, and he will keep as well. Okay, this is the third thing. Another, when every peer got the block, they will first of all decode all the transactions from the block. Okay, and they will validate each and every transaction. But before validating the transaction, they will validate whether block have proper signature and not. So when orderer create a block, they sign the block as well. At the end of the block, there will be a signature. That validation first happens at this phase. And finally, they decode all the transaction. Each peer will decode all the transaction within the block. And first of all, they will validate whether this transaction has sufficient endorsements or not. Because as per the endorsement policy, the transaction should have sufficient endorsement. So that validation happens first here. And once the validation happens, finally, if everything goes well, that transaction data will get committed to the ledger. Again, ledger have two parts. First one is the current state database, second one is the chain of the block. At both of the places, if everything is fine, this transaction will get submitted to the ledger, current state database, as well as the chain of the blocks. One more important thing. So general, this question get asked in the interview or it's related to Hyperledger Fabric only. How consensus is achieved in the Hyperledger Fabric? Okay, consensus is the three-phase process. First one is the endorsing phase, second one is the ordering phase, third one is the committing phase. Okay, when this client, this API server is sending transaction to the target peer and other peers are endorsing the transactions because this peer is sending to the endorsing peer as well, the same transaction. So this is the endorsement phase where first of all, user get validated whether he has a proper signature or not, whether he is allowed to do the transaction, and finally this transaction will get simulated using the smart contract and created reset and write it. This phase is the endorsing phase. Second one is the ordering phase. When this peer collect all the endorsement response and send back to the orderer just collect this transaction chronologically and create a block as per the criteria we define. This is the ordering phase, and that is the second one. Third phase is the committing phase. When orderer block to the leader peer again send to the other peer in the organization, and again validation happens. They decode the transaction and validate one by one whether it has sufficient endorsements or not. So other validations happen, and finally committed to the ledger. So this is the third phase, that is the committing phase. Along with this all the phase, we can say we are achieving this consensus in the Hyperledger Fabric using this first endorsing phase, second one is the ordering phase, third one is the committing phase. Okay, one more important thing, you might be confused. Like I'm saying this is the committing peer, sometimes I'm saying leader peer, sometimes I'm saying anchor peer. Okay, this different peer role are very important. So you have to understand that first phase when we are sending the transaction. Okay, at this phase, this peer 0 is acting as a target peer. Okay, don't worry about the target. It's not something different role. Target peer is means this client will connect, this API server will connect to the peer. And at this point of time, this how peer 0 know other peers are up and running. So there is anchor peer role, which is responsible for getting all the data from the other peer, like who is up and running in the other organizations, in the current organization also. So that all the information managed by the anchor peer. And when this transaction is getting sent for the endorsement, this peer will act as an endorsement. Each peer will act as an endorsement at that point of time. Third, next one, when this orderer create a block and send this block to the one of the peer, that is the leader peer. Okay, this leader peer, it means order is sending a block at that particular time. One of the peer will be the leader peer in the organization, and that peer will act as a leader peer. And finally, committing peer, everyone simulate the transaction within the channel and chain code, and they commit the data into the ledger. At that time, that peer is acting as a committing peer. So in this way, we have total 4 peer: anchor peer, endorsing peer, ordering leader peer, and finally committing peer. These 4 peers are very important to understand. So make sure you understand this, all the 4 peers responsibility within the transaction flow. Same peer is acting as anchor peer, leader peer, endorsing peer, and the committing peer, but at a different point of time. So this is very important thing. So another one thing, when we're talking about the document management, what kind of transaction flow we have. But before that, one more thing I wanted to let you know. This validation is how validation is happening. We created the signed up proposal here, okay, and sent this endorsing peer, how it is validating. I mean, this is general flow, signature validation. Let me just show you. When this endorsing peer get the signed proposal, they will just decrypt the signature with the public key, and public key is available in the certificate. So along with the signed proposal, we will have the certificate of the user as well. Okay, they will decrypt with the public key and we will get a digest. Okay, one more thing, we have proposal byte as well within the same signed proposal. So this endorsing pair will create the hash of this. If these 2 hashes are equal, it means this is the valid signature and no one has tempered. And if the public key of the certificate and the certificate is valid, it means that transaction has initiated by the valid user, and if it has a permissions and all, that will get successfully initiated. Like means this endorsing pair will validate this transaction and it will create a read set and write set, and finally create one more signature for his own. And finally, at the committing phase, that endorsement are validated here. In this phase, when orderer send a block, this committing pair finally just decode the transaction first, validate whether it has sufficient endorsements or not, Second one, again, each endorsement will get validated because he don't trust on each other, right? These organizations don't trust on each other. They will just validate if the transaction has sufficient endorsements or not. If they are insufficient, each endorsement should be valid, and that validation of the signature will take place just before sometime how I explained. Okay. Now let's talk about our document management application. So we have a different flow. I mean, we do not have three organizations, we have only two, and each organization has only one peer. Let me just show you that flow. Okay, here the client is initiating the transaction. It's going to the peer 0. Peer 0 is sending for the endorsement from the peer 0 organization 2, and both of them are endorsing the transaction. Finally, sending this transaction proposal to the orderer. Orderer just chronologically ordering the transactions and creating a block, signed a block, and finally sent to the leader peer here as well and here as well. And finally, these peers are acting as a committing peer. They will just decode all the transactions. It validate each and every transaction, whether it has a sufficient endorsements or not. First thing. Second one, whether each endorsement is valid or not. This validation happens, and finally, transaction is getting submitted to the ledger. Okay. So in the Explorer part also, I wanted to just show these things. Okay, here we can see any transaction, just open it. The transaction ID, validation code is valid. Payload proposal, creator of transactions, how many endorsements are there. Right now, only one endorsement is there for this particular transaction, because as per the policy, we had only one. Chain code name, type of the transaction, timestamp, link, read side and the write side. Yeah, this was the thing I was talking. During the endorsement phase, these read side and write side are created, and there are some endorsements as well, right? Argon MSP is the endorsement. I mean, it's not fully detailed, but in the postman, when we hit the get transaction by transaction ID, we get all this information. We can see here. Validation code is 0, that is the valid only. Okay, it will be available at the end of the block. So that there is one more interesting thing I will let you know later on. Transaction envelope, payload, having this different data. Chain code proposal payload, it's having other information and the endorsements as well. Okay, this is different transaction, and that was the different. So it's having two endorsements, and for this transaction, it is showing only one. Okay. All right, this was the important thing actually. So make sure you understand. Just try to see this video again and again, because it's having a lot of important information. So one more thing here. We'll just go through one flow, proposal flow. Okay, from the top to bottom. This is a proposal. This user is creating the transaction proposal, function name, agreement, chain code name, and channel name. Sign proposal, how it get created at the API side. Okay, this is the first step. 0 step was this one. Signed bytes are added, certificate is also there. Finally, endorsing peer will get endorsements, and finally they create the read set and write set. This main target peer will collect all the endorsement from the peer, and it will create this proposal. And finally, signed transaction proposal gets sent to the orderer. Orderer will create the transaction blocks. So here there are two transactions and the signature also at the bottom. And this finally gets sent to the committing pair. That is the leader pair, but finally to the committing pair, and that validation happens. Okay, this was the overall about the transaction flow. You might be wondering about the leader peer. So why I explained here. See, leader peer is the peer which got introduced in the network because of they wanted to reduce the burden on the order node. So that's why they introduced the leader peer. Okay, one more thing. I was talking about the leader in the ordering cluster as well, like who is the leader and all. So that flow we are going to see in the next video, how exactly this orderer communicate with each other, how they replicate the lock with each other. And if I'm sending our transaction to the orderer 1, 2, 3, and how they sync this data and who will be leader at that particular time. So that part I will be explaining in the next video. But yeah, this was the overall about the transaction flow in the Hyperledger Fabric. So make sure you understand everything. And these are the steps. 0th step, invoke to the API. First step, send to the target peer. Target peer will send to the other endorsing peer, and it will just endorse himself as well. Finally, once you get the endorsement, finally send to the orderer. Orderer will send to the leader pair to the committing peer finally. And during this phase, even the leader pair will also do the same validation, because they also have the ledger, right? Whoever are the part of that particular channel and chain code, they will have this ledger. That's it for this video. Thank you so much.